and very much low. You can make it memorable that your whatever information you're taking away that can be useful. On behalf of Indians of Packaging as well as PG Chamber of Commerce and all these industries organizers, we welcome you here, especially the speakers, those who are all the way from different country. Mr. Miroslav, who is the key speaker of this session. I welcome you, sir. Before I introduce him, I would like to tell you something. Package is a combination of art, science, and technology, not one subject, which ensures safe delivery of the product to the consumer in a sound condition, factory-fresh condition. There is a key sentence which used worldwide, the function of packaging and what packaging is. Besides this, packaging serves the whole world, mankind, time to time, to give the convenience for living, convenience for use, technological upgradation, material upgradation, innovations. Every time it is happening worldwide. That's the reason today we being a consumer conveniently getting all the products in your hand. Even in the lockdown period, nobody have suffered any problem from the any type of product needs in our lifestyle has reached within time. We are thankful to the industry who got involved to serve to the mankind for all packaging requirement to fulfill. And we have there are three types of industries who are involved in it. One is the material, packaging material I'm talking about. One is the machines. Without automation, nothing comes. 130 crores people living in India. You can imagine this is a population I'm talking India. Worldwide, the big population. Everybody needs in the morning one tube toothbrush to brush his teeth as well as this, as well as make his good face to have a cup of tea. It's milk, in his tea, it is sugar. Everybody needs. Do you think that without automation it's possible to reach everyone? 130 crore people they need milk pouches in their hand in the morning. Automation makes it possible. The morning you're getting a pouch from the shop, your tea ready, toothpaste you're getting in your hand, and imagine in the car. I've seen that oil people should come in glass container, wide mouth. You have to take it like that. Of course, not the toothpaste I'm talking about. Tube technology made it possible. So all oil made semi-liquid product to fill in. And through automation, it is filled in high speed and all type of convenience, easy to open, easy to close, easy to check, easy to display, all type of things time to time it has started coming in. And modification came with the convenience, all type of compatibility with the migration, convenient to use it, all type of facilities provided as per the lifestyle requirements, demographic requirement, marketing needs, display technology, all the things have been overcome. Today time has come to see what the new things are coming up. Every time people are asking what new, what new. The conference is the place where new technologies are coming. The conference is the place where all these innovations people are waiting for to give you what new. Today, we are very happy to introduce such personality who has given his whole life for this type of technological development. Mr. Miroslav is with us to talk on what the new technology is serving for the collapsible tubes. I have seen, I remember, I'm talking with that because we have less speakers today. So that's why I say Let me speak a little bit, then I'll give you slide. I remember when I started my career in 1985, first visit I made it at SL Packaging Limited Bombay, which has been changed to the SL Pro Pack. They were making the laminate tube that time. Before that, I visited Patel Extrusion Limited, Impact Extrusion in the aluminum collection tube. I'm talking the tube technology. Today, all the hurdles have been overcome. Technology, what they are saying that you can get the raw material at your factory. You can make the tube by machine, and you can form the tube and filling, sealing there itself without any contamination, without any type of difficulties faced. Technology advances have made it possible to. So we'll listen on the technology from Mr. Miroslav. I would like to introduce him first. He's our first speaker. Mr. Miroslav is a veteran of the laminate tube industry with expertise in the design of manufacturing of unique technological equipment, automated lines for the production of laminated tubes and tube filling automation. Mechatronica is a company located in Roma, Bulgaria, has developed innovative machine offering best price performance packaging machinery for laminated plastic tubes, form fill seal equipment, the FFS. Laminate tube in the FFS form. Okay. And liquid cosmetics, semi-liquid, and dermatologics. This is the product brand which is being formed. Especially forming of the equipment for metal containers for the last 60 years. So with this much, I welcome Mr. Miroslav and request you to please give your presentation. Please welcome.
Thank you very much, and thanks for inviting me to talk. I would like really to present something that is new, and I hope and we hope that this technology will give a lot of new opportunities in the packaging industry, especially in the chip making industry. So let's start our presentation. I don't know where it is.
Who's IT person, please? आपका presentation complete. आगे. Can you help you?
So you see, technology always carries some risk. This is one thing which I really want to pay attention and present how important is technology not to be just good, but to be reliable. Because whatever technology we have, even if we think this is the most advanced technology and could be vehicles, if this is not reliable, this is not good technology. So this is something very, very important also, and we were trying to improve our machines and technologies also in this way, to make it reliable. So if you get problems like this, one, two, three times with any machine, and then you start not trusting to this technology, into this machine. And then this is not good.
Okay, I think we have today Professor Ghosh. He is in the online, so he is not here. I can see him in the screen. Uh, Professor Ghosh, sir. So, good morning, sir.
Yeah, good morning. Good morning.
Sir, very nice to see you, sir. And we welcome you, sir, in this conference. And the time will be coming when your presentation will be announced. And it is a virtual plus, physical both together. So, in the mental Yugoslav is speaking, arranging his video, just I am speaking to you. And please be with us, sir. And when Miroslav will be finishing, next presentation will be yours. And before that, I will introduce in the next minute, sir. Please be with us.
Okay. Thank you.
Thank you, sir.
I will start later, no, after the first lecture.
Yes, sir. Yes, sir. After Miroslav, his lecture will be over, then I request you to give your presentation, sir. Please be
Thank
with
you.
us.
Thank you, Madam. Thank you.
Thank you. What is the problem?
Okay, so I will start without even this presentation. What I'm trying to present you is new technology for making and feeding tubes. You will see what's new here, because of course every tube which is made is dedicated to the field treated product, right? So you are not making tubes to just craft them. Of course, in general, there is nothing new, but if you just make to put, let's say, so in some box, move to some other place, then work on how to make machine and do it, different. Of course, you may put both machines nearby, tube making, and then filling machines also, filling machines nearby, and do some kind of conveyor or whatever to transfer the tubes from one machine to another. This approach also exists. But the problem with this approach is that tubes are not so easy to be transferred, one thing, especially when you go to materials like material with very fragile, very soft material. So this is difficult. And plus, you have in this approach to making machine, to filling machine, you have a lot of units. You have on the to making machine some offloading units which also somehow not linked in the box. Then somehow you need to transfer this box, or it's like in some cases it's case, but still some unit to transfer to. Then from this case or box or the filling machine, you need to pick up those empty tubes, work on certain kind of transferring units, some kind of carriers, shuttles or whatever, and then you start filling. All this in the immediate units any problems. As you already see, any complication in the technology is risky. So you have efficiency of the core line, which is multiplication of efficiency of each unit. If efficiency of each unit is greater than one, which is normally like that, if you multiply 10 times 0.9, for example, it becomes, I don't know, maybe 0.5. So this means that half of the time unit is working. So our target is not only to make the whole process to making and feeding, but also somehow to simplify this process. in order to make it as simple as possible and respectively as efficient as possible. So that's what is new in what I'm going to present. It's one machine, which in fact is skipping some of these steps, which make it more efficient for reliable. Okay.
Is it ready? Ready हो गया? Yes, sir. So you can start giving presentation, video on कर दीजिए, सारा वो दिखाएंगे. Okay. Full screen में दीजिए. Full screen में दीजिए.
देखो. No, if you just read a normal, it's not very complete.
Can you make it full screen? Yes, sir. In full screen है? ठीक है. Sound please, sound.
Okay, video of the machine, okay, maybe first to show presentation and then.
Put on the presentation also. You want to see the presentation. शुरू से दिखाइए, शुरू से आप वीडियो खत्म हो रही है, शुरू से जाइए, साउंड के साथ दिखाइए. You want to yes, presentation please. First presentation.
Okay, good, please work. So first, just brief presentation of the companies which I'm presenting. In fact, I'm shareholder and CEO of company called Megatronica. Megatronica is part of a company called Polytype, which is this company. And Polytype is a leading equipment manufacturer from Switzerland, as you see on this presentation. They're making equipment for packaging industry, food, drink, cosmetics, and pharmaceutical, and they have experience for approximately 6 years. Mechatronica, my company which I'm presenting, is in Petrico, Bulgaria, small country also, city is called Gavrovo. And for last 23 years, we are doing machines for laminated tubes. And there is also a company Polytype India, which is a subsidiary of Polytype Switzerland. And this Indian team is also carrying sales and service here in India. Because, of course, all these technologies are enough complex and they need the service. Every machine, people not just run without any service. Okay, this is picture of the company and the team is working, approximately 80 people working there. The company has a long history, about 6 years of company, and was always a company for high technology, for new technologies. Many new developers were there through the years. And to make a machine, we started making already 23 years ago, but before we had technologies that are part of tube making by conduction, especially. and the knowledge of this technology is already helpful. So this is one of the machines, in fact, the first fully developed model, which already sold since, I think, around 10 pieces already around the world. This is Combis trade name, F1060. And this machine, we are marketing as machine for short run jobs. I will tell you briefly before talking about this, what was the history of these educational machines. Because reason for starting those machines was a little bit different. We were working with Hindustan Unilever in India for 2003, and then as we were doing keep making machines, we developed for them, I think it was 2005, also technology for making orchids. But then it's only we order for them, not around. When those tubes today started putting in the filling machine, because of the shape which is not round, you normally filling machine, they put them in some kind of magazine and they start putting one by one to go in the machine. Because of the whole shape, those tubes were not going to turn. Yeah, so there was problem with filling machine. And then how to fill those things, how to work with that. Therefore, we were thinking what we can do, and then this idea to combine keep making and to filling came. The first reason was to be able to manipulate those oval shaped things. The second idea, which also came in mind at that time, was why not to try to also use steel material? Because especially these tubes were small, and the idea was if possible to make with thinner material, so to say, material. I say cost. The time cost was most important. Nowadays, also environment application is important. So we made one machine like that. I think it was almost 15 years ago, which was not with machine, but was using this technology. Again, machine was running, it was installed in Halifax, not far from here. But with this new material which we're using, customer perception was not so good, and then Unilever decided not to use this technology. Uh, for a while. Okay, now they are getting that impact because now materials are important. So we developed this technology, we continue to develop, but then we targeted another area. This was short run production. And there was one area which which I'm not mentioning in this presentation, but I think it's also very important because of the advantages of this technology. This is the pharmaceutical industry. So we are talking here mostly for short-term jobs. Before many years ago, idea was to produce products like toothpaste, creams in very big numbers. Of course, this make production very efficient. This is the best way to make everything efficient and everything cheap as possible. With one place, big machines, high speed, fully automated, everything good. You produce one, two, or three types of product. And then through the years, the customers' habits changed. And now we always ask about new things. And you see, even here we are talking to what is new, what is new. But the same question people are asking for products they are buying in the show. They are looking for something new. So this means producers of these products, they are under pressure to produce more and more different types. And because numbers cannot grow without yield, so if there are more numbers, one type of product means less number of each product. So this means batches of production will be decreasing. And then in many areas, these huge production facilities with wide capacity, which is really very big, they were becoming kind of not very efficient because that's why it's usually not very flexible. You need to change a lot of things if possible, at all, in order to change product size or whatever. Therefore, need for short run machines or short batches was there. And evidence is, we think, perfect technology for that. So, here you see some of the advantages of this approach. In Rock, run machines, which is also a big problem, of course, because when you run high speed and you have even less than 1% number of scrap tubes is high. Uh, and therefore we developed this machine dedicated now for this short run production. Okay. Here you see the process. As I told you in the beginning, idea to make database is not just to combine chip making, chip transfer, and chip filling in one, because this is not the best approach. You have some processes which are not really necessary, and if you are able to help them, of course your efficiency is increasing. So as you see from this diagram, process is here is simplified. Uh, I can't remember. So first process is to form the body. So you take 1 minute, which you see at the bottom, flat 1 minute, you wrap around the member, then you do filling, and then you do trimming. So this is the body making. This is the only process which exists in the baking, nothing new here. Then next one is putting shoulders. In this technology, we are using process with so-called pre-molded shoulders. There are two types of technologies for making tools. Okay, you may say even three, but one technology is where shoulders are coming ready, made on injection molding machines, and tube making machine is just assembling machine. It's another technology which is in two versions, but in both versions, two shoulders are made online. So one is with compression molding, which is more efficient in many ways. Another is normal injection molding. At first, very first tube making machines, which were made in the United States, company called American National Chemical, they were using injection molding technology. And this technology is still good. But anyway, both these versions, compression or injection molding, they make sure that's online. Here we are using pre-molded shoulders, and there is a significant reason for that. If you do injection of the shoulder compression, which is saying method plastic, then there are some kind of operations from this method plastic, which you will try to not to have in the tube when you fill the product. So you need certain time when all these gadgets are going in the tube. So you cannot afford to fill tube immediately after injecting or making sure that the metal plastic. Here on this machine, of course, after making tube filling is after 2 seconds, 2, 3 seconds, depends on the technology. If you use compression or injection molding, you need somehow to collect them, keep for a while in some storages, and then continue filling, which we don't think is good. So we're using pre-molded shoulders. The shoulders are made ready, and then they are just molded on the machine. Then we seal put into the shoulder and put tape if necessary, because also if it is technology, we will discuss a little bit later. There is also option to integrate the shoulder and cap as one piece if it's mostly for saving material. But if cap is separated, you put cap. You also may put before cap. You may put also membrane if it's required. This all is a part of the standard because and then we are coming to the next process, which is transfer of the tips. Here is the trick which we are using. In fact, the idea is to avoid period of time where tip is split. not on the manual, not in the hardware. That's the real problem because if you're going to especially to use very thin material, it's very soft. And you get no way, not stable way, good way to hold this tube and transfer it. Therefore, in this machine, this is what we are doing immediately from the laser when to be placed. We are transferring in another corner. Okay, we are holding this time outside, but there is no time when tube is in fact free. It's always under control. I know we're joking, but there's also like the things like projects and future especially like small children. If you leave them free for a while, you don't know what they will do. So that's the keep control. So this is most important part. In taking it immediately transfer to the filling station without leaving it even for a while. And then it goes to the filling station, filling unit is not some special unit, we using standard technology. So the filling depends on the material, we may use induction filling event or a hotel, of course, all this stuff which is there. Here process it in more details. It's the same what I already said. Body making, galvanizing, typing, lift cutting, transfer to the heading with pre-molded shoulders, body molding, shoulder welding, tube capping, and then we have transfer to the filling table, filling unit. And then on the filling we have orientation, and we may avoid skip orientation because in most cases we know position of the tube because here I'm representing a 60 this machine. In this machine, in fact, we don't have orientation, but we are also doing a little bit high speed in this machine where we are losing a little bit of orientation. So orientation sometimes is necessary. And then orientation you need because of the physics. You want this phase of the tube to be in one side only. And then you get filling event, and then cooling on the sealing part. Also here is the operation, but it's important part of this. Some coding. Coding could be done in different ways, and this is in fact one of the advantages of this technology, which is not mentioned. You may put if you use for example inkjet printer, you may print on every tube unique number. So you may trace each tube. If this is done with standard technology, usually this is not possible. But here, because in standard process of tubes, okay, you may still use inkjet printer to put unique code on the tube, but you almost never have information about the whole process. Where raw materials are coming from, where shoulders are coming from, because you want to trace everything. And here, because process is combined, when you make this tube, you know batch number of the toe, you know batch number of the shoulder, you know batch number of the cake. Of course, you know all information of the product, batch number of the door component. So when you print this unique number of the tube and you get some database in computer, you may get information for everything related to this product, which is very important for medical products, of course. For toothpaste, usually, or creams, this is not so critical. But for medical products, it's extremely important. You know, now with this vaccine, they are talking for some batches in Europe, especially that they found them quite risky. So it's very important to have batch number and to know what is there. Okay, so next point here is contamination. This is, as I said, extremely critical for pharmaceutical industry, but also in some other areas, our care, of course, is also important. Okay, as you see here, from the time when you start making tube to the moment when you fill this tube, it goes through different stages and also usually two different places when we use standard technology. First tube is manufactured somewhere, then it's packed in usually in cartoons. Those cartoons also can create some contamination because it's not perfectly clean. Okay, sometimes they are wrapping in polyethylene base, but this process takes time. So there is always the risk of some contamination from the cartoons. Then, especially this tubular material, which is a plastic-based material, is very sensitive to static energy. Because there is no conductive material inside. In ABS tubes, you have this aluminum layer which is distributing somehow these charges, but in plastic, especially, this is not possible. Therefore, in tube making, many times you do static discharging, but you can do this from outside. But you cannot do from inside the tube. Okay, you may do, but it's extremely difficult. So usually, even if do from outside, you have static charges from inside of the tube, and then when you put in the box, whatever dust is there during this sonic rotation, it may go inside to the tube and stick to the inner surface of the tube and stay there. And then during filling, removing of this duct is not easy at all. We have customers in Japan who is using advanced technology. They are very sensitive to this. They put in their filling machine before starting filling our technology a lot of complicated systems to remove and clean everything from the here, this is not a problem because even though, of course, in every static charge, but as filling is done just 2-3 seconds after tip making, and also usually machining in clean environment, there is no dust usually there. So this problem does not exist. So this is very, very big advantage, and guys in the pharmaceutical business like very much this. Of course, in other cases also good. Then the next advantage, which is here most important than for oral care products, is cost. In pharmaceutical business, usually cost is not a big issue. And the medicine is usually expensive enough. But in oral care, cost is a big issue. So, main advantage with using FBS technology is in thickness. And why we can use continuum material? I told you that the main problem, which we are also solving, is transferability. If you use thin material, tubes are very soft. And then transfer of these soft tubes while they are out of the middle on the tube making machine until they go in this holder on the filling machine. It is very difficult, and in particular of the material below certain level, it's practically impossible. So they go on this machine, we can make very tiny tubes. Just to give you an example, our standard laminate thickness at the moment, which is used for ABL, is something like 220 microns, at least 1/5 of the millimeter. This machine we were testing with 120. This is almost half of this material, and it works. It works without any problem. So you may save a lot of material. Half of the thickness means half of the cost. Which saving. Because usually coil is the most expensive component of the tube. Is usually taking sometimes it depends on the tube, of course, size and shape, but it sometimes takes up to 60% of the cost of the tube. So when you use half of the material, you save huge amount of and of course, another advantage of using continuum material, I also mentioned this a little bit later, is the environment, because when you have less material, you contaminate environment less. logistic cost, of course, this is I think very clear. You don't need to put in the boxes, you don't need to store, you need to transfer this. This is of course very clear. There is also one more advantage which is also related to the third point, which is inventory. To freelance, the owners, they usually work with patches, of course, and they need to produce, let's say, 100,000 with their product because always there is certain scrap and certain uncertainty in the process. They order a little bit more. So they need 100, they estimate that they order, let's say, 105 or 10. But you have to get some space, some sort of space to manage. But then they start making this batch. Of course, so they almost never use this safety margin. And then something left, and today something left, tomorrow something left, and after few months, your storage area is full with some small numbers of different type of tubes. We have in our center also our own production of toothpaste for production, and we experience this. You know, we had so many processes of tubes. Sometimes even 500,000, so we were scrapping and there was no other way. So this is also another big advantage here. Of course, you still need some safety margin, but instead of ordering two, you are ordering more for printed form. Okay, as long as you don't have also printing facility, because if you have local printing facility, you don't need even to have printed form with some excess. But if you print outside, okay, you will order a little bit more for. But for you need much less space, and of course, if you need to scrap foil, it's much cheaper than to scrap the whole tube. And really, with advance of digital printing, more and more this technology will benefit from this. So it's completely possible to join one digital printer on the machine, and then you will get no scrap. You get just unprinted material, which is universal for every tube, and then no scrap in this way. Storage space is also very clear because you don't really need storage, or at least you need only storage for core, which by volume is maybe only 1/10 of the volume which cubes get. Very easy to store core. So this is advantage which I want to discuss again. Not another tubes, have another problem. As I said in the beginning, little more and more capital, more brand users, brand owners are targeting small ones. But to make short tube, you still need to produce these tubes, and as tube making is a process which requires tube changing settings. When you start making these tubes, you always have some scrap until you adjust this machine, and then you have this on the making machine, and then it goes to the filler, and then again you do some adjustment. So during this process, when you do short runs, you always have certain level of scrap. Using chemicals, you significantly reduce this scrap because you skip some of the process. Of course, I cannot say it is not scrap at all. But the reduction is quite significant in terms of short run jobs. And lead time in some cases is quite a big problem. When you need to order a small number of tubes for new product, manufacturers usually guide machines. If they accept your order at all, because most of the time they are not even ready to accept there is no order. But even if they accept, they put at the end of the priority list. So they usually make those tubes when they get some some time for doing this. It could be a very long time. We have some customers that are running very, very short jobs, short means even sometimes down to 5,000 pieces. They have no other chance. They get no other chance. So no one from chip manufacturers is going to make 1,000 or even 10,000 pieces of chip. And this is usually true not as much in oral care area because oral care is relatively big number. But we using also this type of FFS machines for food products. Many food products are produced in tubes. I don't think in India it's doing that much, but in Europe you see more and more products, food products are in tubes. And then usually because there are many types of this, but the others are small. Also technical products like grease, silicone, some glue, even some paint. One customer is doing some putting some paint in. So all this is very, very short run, 5, 10,000, 15,000. Pharmaceutical industry also, we were talking with a few times with lots of clients, GSK, they said they have 15,000 of different type of tubes. It's not that they have 15,000 different type of talent, but because in medicine, you need, especially in Europe, is a big problem. You need to print some text in all these languages which exist there. And they have one type of color, but they need to make 20 or more different tubes because of the printing. So their batches are becoming really very, very small. So you can imagine 15,000 different types. So this is big advantage of technology also in this way. We just have different products. Hopefully, if you can digital print it, even this is not a must. Okay. And carbon footprint, I already talked about this. Main reason why we can say you can fit is because you use steel laminate. But also, as I mentioned, you may do a combination of chip and shoulder in one piece, and then it also helps to save. Of course, the chip and shoulder combination you may go from another to make it much. This is not just for the but really thin material is something that you can do only on really thin. I mean, something like this, 120 or probably even and also during transportation, you of course you also spend some fuel and also it also help a little bit to save this footprint. Here is just brief data for this Ictm machine. For type as you see, ABL PBL, for thickness as I said, ABL 120 to 400. PBL so far we never did something that 220. I'm not sure it cannot be done, but we never tested because we didn't find such a material so far. But most probably it will be possible. But the ABL we tested and it runs very well 120. Speed, PBL there is some difference. I don't know exactly why. But this is related to tube making. Why there is difference is because how you seal the tube. You first coat out this plastic and press it, and then you need to cool it down. When you heat it, if you provide a high thermal gradient, so it means you heating agent, if this is air or maybe induction, you may heat this particle to 200 degrees. Okay, usually more than 300 is dangerous because there are structural changes in the plastic, but at least you may hit 200 degrees. So if you take from 20 room temperature to 200, you have high gradient. So heating transfers relatively fast. So heating is it could accelerate progress. But then when it goes to cooling, then it's another problem. You hardly can achieve this 200 degrees difference. because what kind of cooling agent do you use? Normal water, which is standard and easy to use, so you could go down to 4 degrees. And 4 degrees is difficult to achieve because there is a lot of condensation, but let's say you could go down to 4. And the difference is not that much. You may use some gas which is cold, but the problem with gas is that the thermal capacity of the gas is very, very low. So you need to burn a lot of gas in order to take out all this energy. So cooling is usually taking longer, and in case of area, this metal, aluminum inside, it transfers this heat. So it disappears much faster. In case of fuel, there is no metal, so the heat takes longer to therefore speed it. So diameter, radio again, challenge, we also get one machine that is doing even 10 millimeter tube. But this 10 millimeter tube is not very efficient because it's much more material like pearl and shoulder, cake, whatever, and the brains inside there are 2, 3, 5 milliliters of product. So this tube is more packaging material than product inside. But it could be made. And then length 90 to 200 also could be reduced a bit. And that's it. Thank you, and if
We like to show the video now.
okay, yes, it's good to see video because you will get more information about the machine. This machine which is on the video is for our customer in Japan. It's not HK60, it's HK80, so this 80 to million. This company from start, they're using now only HK technology for the tube production. And they produce toothpaste, they produce some cream, only so the last thing is to do I don't know whether you can hear you probably can hear. This video is kind of initial video and so here is body making, cutting of this body, it's rotary cutter, then it's transferring, now it's immediate to table, because it needs also orientation. Orientation is time out of the then it's transferred to the tube making part. Okay, those are shoulders, body shoulders. We wash shoulders before washing the body, then wash body, then we do sealing of the shoulders, and then this looks like caps coming. In this case, those conical caps, simple caps. On this table, we also can do orientation of the cap in case there is anything from the cap. And this is the capping, and then this is transferring to the feeding process. Feeding machine is controlled with feeding process. But feeding machine, as I said, not very much different from standard feeding. Most important is really this moment of transfer. As you have seen, tube is pulled from the mandrel, and immediately head of the tube is going in the holder before it left the mandrel on which it was made. So there is no even fraction of a second where tube is free. It's really very important for thin material. If you have thick material, stable tube, okay, you may do many ways, you may use many ways to transfer, but here you cannot. Okay, so thank you.
Thank you. Thank you, sir. You have shown the information how mechatronic has made the innovative machines. The machine's flow has also been shown that how body making have been done, sealing of the shoulder manufacture, the injection molding process, then capping to be done by mechanized system, and then filling of the liquid or paste product, semi-liquid in the same automatic machine, finally closing. And he has also discussed how it has been transferred to the corrugated colorful carton to free from the any contamination and dust. It's very important for this thing to discuss. He has discussed that what are the advantages, like it is reduced in tube thickness, lighter in weight, less in logistic cost, reduced inventory cost, reduced storage space, digital printing is possible, remove high cost short run jobs. Especially this is the things which is highlighted. Many people are asking for the small quantity to be travel around or have to be produced immediately, requirement is less. So this machine is advantages are for that. Remove lead time for making. This is another thing which is commercially very important. Normally lead time is issues for all this commercial production. That anytime order given, then immediately they can put on the machine and get the things ready, and it can be produced and we can be filled up. And he has also discussed about the specification of the machine. Speed is 60 tubes per minute and different diameter. Two different types of production he can do, ABL and PBL. And lastly, he has said it's a food application in Japan also, they are using this machine. So in this regard, I would like to mention industry of packaging. We have recently done a project on packaging of jaggery, liquid jaggery in laboratory, and that has been introduced in the world market. Very beautifully worked for the food, that means the jaggery, liquid jaggery in the laboratory. So he has also said that food packaging is possible. This another era is open for the new technology in the food packaging. So thank you very much. Please give a big round of applause for his presentation. Now we will be requesting for the question answer. Yeah, question answering. Having a lot of questions we are expecting from the audience. We're gonna ask questions. The video slot is waiting here and he will answer. Please, question please. Online question can we take up? We cannot take up. Okay. The offline, anybody is having any question, you can ask. If you do not have any question, I have one question for you, sir. Especially in Indian industry, from industry side, I am putting this question. They are obviously asking for the machine cost. How much will the cost of one machine to be imported in India? If you have give some ideas, so it will be helpful for people to have some idea. Rough idea, don't give me exactly, because many people they are thinking automatic machine is very highly costly. They are having impression here importing machine is very costly. So anything idea like roughly how much I think Mr. Covid Mahajan is here, he can help you to give some indication because a lot of people are waiting for this type of machine and it will be coming for. So if you give certain indication, then it will be helpful for the audience.
For this machine, what is more important rather than cost is the utilization. When someone comes out with a new technology, one needs to understand why that technology is required. Now, today, if you see any market, take out any management book and you will find two words there, golden mantra there. The first mantra is customer segmentation and the second mantra is validation. So what happens? In good old days, there used to be one shampoo for the entire family. Now, if you see in the market, what they have done is they have done a customer segmentation very, very widely. They say there's one shampoo for women, one shampoo for men. So what has happened is initially there were 1,000 tubes required. Now we need 500 tubes for men and 500 for women. Or maybe I'm wrong. It might be 300 for men and 700 for women, considering the hair on it. But what has happened is the initial amount of 1,000 tubes has gone down to 500 or 700 So now we have 2 seconds. Going ahead, they have done one more valuation. They say a special shampoo for oily hairs. So from that 500, now we have two variants, which is for oily hair, one which is for normal hair. So it is coming down to 250 each. Furthermore, they will come out with something like anti-dandruff shampoo and things like that. So what is happening is initially the job run, the production which used to be in large quantities, it is coming down from thousands to hundreds. And it's a pain point for both the manufacturer, the tube manufacturer, as well as the brand. Because when you are manufacturing small quantities, you end up wasting more material and your changeover time, the machine down, machine unproductive time is also high. So you end up paying more for shortened jobs. So when we are looking at cost of the machine, rather than looking at the cost of the machine, one needs to see how much saving one is going to achieve by having the solution in-house, where we can address this issue of shortage. You may say, just to give an indication, this machine could be around 7 crore rupees. But then at the end of the year, what you are going to achieve is a lot of manpower, a lot of wastage, and of course a control on production. So I hope that answered the question.
Yeah, thank you very much. See, this type of information is very important for all of us from the Indian spectators as well as participant. One more thing, what I have seen that Lamitu or tube technology is improving and its market is also improving. World market is showing around 6.2 billion US dollar. 6.2% and total market is 9 billion US dollar. Right? So that's showing that how fast it is growing. We'll be looking at that fastest growth of this new technology. We'll be closing this session as there is no question. So we give a round of applause again to the speakers and finish the video. Now we will be going to the next session. First of all, I would like to tell you there is a three speakers here. One more speaker, Mr. Venkatesh is not there. Professor Ghosh, he is in the online. I would like to welcome Professor Ghosh with the round of applause from here in this audience forum. Professor Ghosh is a distinguished and renowned professor in the field of polymer science and engineering at Indian Institute of Technology, Delhi, India, and fellow of National Academy of Science, India. Professor Ghosh has over 30 years of research and teaching experience and has 12 patents to his credit. He is known for his accomplishments in the field of polymer processing and rheology, and significantly contributed in the areas of reactive processing of polymer, polymer blends, alloys, polymer packaging, and microcellular. Just 1 second. He has done his chemical engineering from IIT, Kanpur and PhD in a chemical engineering from State University of New York, USA. Worked as a postdoctoral research fellow at the University of Pittsburgh, USA till 1990. Then he joined Indian Institute of Technology, Delhi in 1991. He is a recipient of Young Alumnus Award of Chemical Engineering Department, Calcutta University. Meritorious Service Award of Indian Plastic Institute, Mumbai, India. He is a recipient of Teaching Excellence Award by IIT Delhi in 2015-16. He held the prestigious Reliance Chair Professor at IIT Delhi. He has supervised 30 PhD theses and over 100 intake theses for his innovative development. Please welcome Dr. Ghosh, Professor Ghosh. So I'll request Professor Ghosh to give presentation, please.
Thank you. Can you hear me?
Yes, sir. Yes, sir. Yes.
Everybody can hear me?
Yes, sir. Yes, sir.
I may, okay, has been presented from there. Okay, I could share also from my side. Okay.
Yes, sir.
That's okay. Can you, so Can I share?
Yes, sir.
Yes, please.
Okay, okay. Thank you, Madhav, chairing this session, and it is nice to be with you and all other speakers. And also, I'd like to thank the organizer for inviting me for this talk. Although it will be from my another perspective away from the industry, but connecting industry and what will be needed in this area. I apologize because I thought I could be present physically also, but because of some other academic meeting which is happening here in the institute and some of the other restrictions, as you all know, so I preferred, and I hope I'll be able to deliver my talk with the slides that will be visible to everybody. It will be audible to everybody. If there is any difficulty, please let me know. So let me first share.
Please go ahead, sir.
Can you see my screen?
Yes, sir.
Yes, sir. It is visible, sir.
Can you now? You can see it.
Yes, yes.
Okay. So as I said that I will take you in this forum to a different perspective. I was given to talk in somewhat in this area, and I was wondering how to connect. And in fact, I'm thankful to my previous speaker, Mr. Hinkov, when he was giving all the benefits in his slide with the benefit number 4. He rightly mentioned about uh, the carbon footprint points, and he mentioned 3 or 4 very important points which we have to look into when we are using for this tube manufacturing process and their use. But I will take the audience to understand these in a very different manner, and which is mostly needed now, and that's why I have given the title as recyclability. I hope I'll be able to explain to you that what is the need and how we should go for degree of recyclability. We should think about it. How the recyclability and refillables need to be compared, and when we need to compare, we need a tool, and this tool is what we are being used for the life cycle analysis. It is a very involved analysis. I will just present some salient features of it in this my talk. And so my talk will be mainly that how I'm not going by the preparation process, but when you make some tubes or containers or packaging, then how we make it back these granules and then again go back to the tubes if possible, or in how many ways it can be possible, how we can take care of the environmental concern, and how do we take care of the carbon footprint per se when you are using the number of tubes. I could see even in the question answer session some very valid points about how many tubes should be used, or what should be the size of the tubes, what should be the thickness of the tubes has been talked about. So holistically, one has to look for, let me make my pointer option. Okay. Holistically, when you have to look for a product life cycle, and hopefully that's what I'll be able to converse to. Before I go into my presentation, I have to talk about my department at IIT Delhi. It is one of the established center in polymer science and engineering nationwide, and it is the number 1 in the nation and also globally. But very recently, we have broadened all our activities into what is called a new material science and engineering department, which takes care of all different aspects of materials engineering and material sciences, covering various materials and polymer, metals, functional materials, and nanomaterials and electronic materials. And we also have what is called Center of Excellence established under the Ministry of Chemical and Fertilizer, Government of India, under Advanced Polymeric Materials. And by broadening into a new department, as you can see the inaugural program, as you can the students and our director and all of faculty involved, we also have started new UG undergraduate and master's program in materials engineering, which is already started taking the top ranking students and as compared to among all other institutes and other IITs. The mainly what we are covering are all materials starting from, as I said, soft materials, electronic materials, smart materials, materials for energy, ceramic materials, and composite materials, and that covers the total material science. And you can see different structures and properties and processing that we develop. I just wanted to give you a little bit of preview of our department, and then I move on to my talk. This recycling and the environmental concern is becoming so important that and there are so many ways, every conference, every forum under United Nation and in our India, in many ways we are now talking about the sustainability and environmental program. Very recently, the new plastic economy global commitment has been made, which is under the Ellen MacArthur Foundation, which is in collaboration of United Nations Environments, and they have decided to go for a common vision and targets to address the plastic waste and pollution. There are a number of signatories came worldwide who took part in this. As you can see, close to 200 businesses that are part of plastic packaging value chain are and representing 20% of all plastics packaging that is used globally. They have signed up. 16 governments, countries from 5 continents signed up. 26 financial institutions with some combined support of financially with investors have signed up for this. Leading institution of World Economic Forum and consumer all have come together. And interestingly, more than 50 academics, universities, and other educational research organizations, which include MIT, Environmental Solution Initiative, Michigan University, University College London, all of them have come together and to address many issues which are to be concerned whenever we are talking about tube manufacturing, other packaging manufacturing. We need to look into this, and they have set an ambitious 2025 targets that we eliminate plastic item we do not need, or we innovate. All plastics that we need are designed based on reuse, recycle, or compostability. And we circulate everything we used to keep in our economy and out of the environment. So we have to now go for a circular economy, and we have to circulate. With this, I keep my background presentation is that where we can think of this circular economy solution with the scope of recycling method in the across the plastic value chain for any packaging, whether it's a tube, whether it's a flexible packaging, whether it's a container. And this leakage of plastic waste to the environment is the least desirable. So how we analyze that? And mostly we need to make a hierarchy of plastic waste management. So we need to categorize all products as a single family or multi-family material. Okay, and that has to be done based on the extent of recyclability. We need to understand that everything cannot be recyclable, and whatever is recyclable also has a degree of recyclability, and this degree of recyclability depends on the material, and also whether it's how many layers, how are that they are laminated. Is it laminated with a single family material or a multi-family material? Okay, and how much you have to quantify how much difficult it is to recycle by mechanical and energy impact. That's what we are doing, life cycle analysis, and that's what I have mentioned. And we need to establish best waste to energy solution depending on whatever the calorific value of the different plastics or the materials that we are using in this case. Okay. So no need to say that the plastic recycling is the need of the hour and for the sustainable development. By 2050, we will need 35% more food, 50% more energy, and 40% more water. How do we manage that? When we try to manage that, what kind of material is required? And that's what we say, that waste management to the materials management has to be connected in order to solve. We cannot be biased. We cannot just eliminate one for the other. We need to evaluate every material have its place, and this not only waste management, we have to do the resource, we have to do the material management, and how much from the waste we can bring it to the actual virgin material or as a replacement of virgin material is becoming the challenge, and that is the United Nations directives that we have to follow. And what are the benefits for that? Let's have a look at it. Okay, so we had for the circular economy we have two stages. First stage, we have the collection and segregation, and when we do segregate, we have all different kinds of material, which is from metal, glass, polyester, rigid plastic, plastic films, cardboard, paper, etc. We need to segregate, and then when we segregate, we have a value chain. There can be plastic rigid value chain, there can be plastic flexible value chain, and that has to be connected together, so that finally we reach a product and which we call a cradle to cradle system, where the collection and segregation, and I've written that this is a challenge, that how do we segregate this material and grind this material and get this plastic granule. This is where we have to reach. We have to do a lot of research, a lot of technology development. Not only we have to develop packaging product or the packages, we have to see that after use these packages can lead to very valuable plastic granule, which is called the post-consumer resins, and which can be converted back into the actual product or go back as a replacement of the virgin material. If we can do that, then obviously we'll have a successful circular economy model that we want to do that. I will go very quickly with this. Where is the problem? Smaller plastic is a big problem. We are talking about lamy tube here. The caps will be a problem. The container caps is a problem. Smaller items which are now has been being considered as a single-use plastic products, which has come as a United Nations regulation. Then our country is now putting that regulation in place. Within few months, early next year, this will be in place. We have to look into it. And when it becomes too small, they end up being treated as a trash. They are not being collected, and they cause a problem also for recycling equipment. We have to look into this, and I have written is not usually recyclable. Either they are not coming back as a recycle item, or when it is recycled, sometime our technology maybe is not allowing it to, or eliminating it from the process. If it is go to flexible packaging, they're recyclable, but proper collection, sorting, and processing are needed. And then if it is a multi-layer, then it's a big problem. And then we have to see that. And there are many of the packages have different layers and with the plastics and as well as non-plastic, as well as in the lamy tube. Also, because of the barrier properties, we are bringing in other materials or liners with aluminum or other materials. And until and unless there have a separation of layers, and then we will not be able to capture this, what I can say, that PCR. So we have to look into that. Bags, as we know, there's a problem, but then it is micron thickness dependency. And I will show you that from micron thickness dependency, how we can add value to the environmental concern by bringing back this material if we are using our technology properly. Obviously, it requires proper collection and sorting, and then they can be recycled back, and there are lots of recyclers are actually working to put it back. Even the beverage bottle or the tubes, they are recyclable. But we have to be sure to remove which are the products are removable, or which are other materials to be separated even among plastic material, so that the container is removed away with the levels, and other recyclable or non-recyclable materials or separately recyclability should be bringing in. So some of the areas of segregation becomes very, very important, and we have to make a lot of effort in this area to do that. We come to lamy tubes. Lamy tubes, now this, I will come to this. This is very well known that there is a recycled lamy tubes or lamy tubes made with the recycled materials are being made. And this is a lamy tube which has been made with 64% PCR into it. So the number of multi-layers which are being involved, we can put our recycled polyethylene as one of the layer with the other tie layers, EV wedge layer for the barrier properties, and with the virgin polyethylene. So bringing back these materials from the recycled into the actual replacement of the virgin material makes a lot of effort and a major contribution for our environmental concern that we have to look into. So what we have to look into is the recyclability of plastic tubes, and these require cooperation between all sectors, and that involves the whole plastic life cycle. That's what we have to look into. And they require modernizing and harmonizing the system of waste management. It has to be done. It has to be done, and in the nearer term, what we have to look into it also, that which plastic should be used for the tube manufacturing or even any other packaging manufacturing. They have to be designed and produced and being used in a particular way. As I said, that we need to move from multi-material to monomaterials. Is it possible or not? And how we can develop this material with monomaterial, which will have equal or better valued properties as it is in multi-material, because that will decide the recyclability. And our effort is that the recycling should have significant aspect for the 230s that we are saying, that we may like to use 75% or more percent of recycled plastic back into making the same product. Please mind that. So we have to design that way. Okay. Multi-material contains aluminium. Can we have new monomaterial structure that will be recyclable and may not have? And this is an example of Neopak. Everybody knows that has been, they have dedicated to make this new monomaterial structure, which are a high degree of recyclability and use of environmental sustainability when we make this product. So all the tube manufacturers has to look into it, because we have a responsibility to take in terms of this. Okay, so we have multi-material plastic tube always. Okay, so in Europe, 20 million tons of annual plastic packaging is happening, maybe even more than that, because of the statistics are changing. Out of these 1 million tons of multi-material combinations, so you can see that about 5% is a multi-material combination, and which cannot be recycled easily. Okay, so if the recycling is also difficult when there is a different types of plastics, as well as there is a non-plastic material is there, as I said. Okay, so there's can we do that, take care of that 5% of the foreign materials, so that the recycling process is not disrupted? So we have to redesign the material and the solution of monomaterials, which I was saying. And many companies, I'll show you some of the, you all know that they are actually looking for the solution, and everybody is coming up with a new solution. So what is the waste hierarchy? We have from most preferable to the least preferable. We do not want disposal. We do not want our packaging material, laminate tubes and flexible tubes and all that to go into disposal, because it will harm the environment, and as well as we are losing the value. So what we have to do, that if we go up to the most preferable way, then we would like to see that there is the energy recovery. We like to see that there is a recycling. The reuse is another one. The reuse concept should be coming in this waste hierarchy, and that will actually can determine the recyclability. We should go for reduction wherever is needed. My previous speaker also mentioned that they are always started avoiding maybe the other paper carton and other extra packaging. Why should we go for extra packaging? Why toothpaste has to be put it in another rectangular shaped box or a square cross-section paper box? Why can't it go only as a tube into the market? Okay, and then there should be prevention of using such material. As we can move upwards, we are actually reducing the waste as much as possible. So the recyclability has to be defined. The recyclability is defined in such a way that plastic should be made in such a way that should be collected. It should be have a visibility, collectability, and value in it for the collectivity. It is not collected. Anything is not collected if it doesn't have a value. and this collectivity defines the recyclability. The product must be sorted and aggregated into defined stream. How do we aggregate it? We have to sort it out. The sorting possibility should be there, and then it can be aggregated, and that defines the component of recyclability. Can it be processed and reclaimed and recycled? Just collecting and sorting doesn't mean we can process it. What are the techniques available? How we can process? What should be combined? What should be the technology used? What should be added with this material to return? As you know that reprocessing and recycling, actually also there's a possibility of degradation of the material. So we should have that also. And the recyclability means that can it becomes a raw material? We always think of that we convert it into something. We convert into a product. We have a value addition, but can we bring it back as a raw material that will be used as a production of the new products and as well as the packaging product? Okay, many of these. This is a RECIC class, and France has defined this, which has been now considered by many as a recyclability means or the prerequisite, and there is a ranking of recycling is being done. What kind of recyclability platform they have suggested? That recyclability, there is an evaluation protocol. We cannot say that this is a recyclable. How much is the recyclability? So there should be a test on recycled product with and without innovation. So we do some innovation, we have to see that. We have to have a comparison of the properties. Then the technology has to be approval. So this is protocol has to be, evaluation protocol has to be approved. Then this will lead to the design for recycling guidelines. We have to give a recycling guidelines and should be transposed to the tool. And overall recyclability of the finished package has to be assessed. And for this purpose, the recyclability tools that is used is the recyclability self-assessment, recyclability is export possibility and checking, and there should be a certification of recyclability. This is the platform which is being developed now worldwide and is being taken out by UN. Now, because of that, what we have done, we have taken up different polymers, their pigment, their for material used for the barrier, the material used for the level. We looked into the adhesive. So one particular packaging has so much of so many different components being added. Okay, so what has been done? The recyclability ranking has been done in many different ways. This is one of the way. If you go from one column to the other, you will see that we move from yes to conditional to no variety. Okay, yes means is full compatibility for recycling. That means the material that is used, the color that is used, the level that is used. So it should be a PE system or poly system. What do you call it? If it is a different, then it becomes different, okay, and the recyclability different. So you can see that I also given a color code from green to red. So as you move from green to red, you are actually in a zone where the recyclability will become meaningless. Recyclability will not have any value. So when you come to the middle column, you can see it's a limited compatibility for recycling. So they pass the testing protocol if certain conditions are met. So you have to work with the recycling with a lot of technological input, because it has a multi-layer system. It has some translucent color system. It is a level which is different. It may be of PP, it may be of paper, but still they are from the same family and there is a limited compatibility. So this is acceptable. But if you go to the last column, we have said the no or very low compatibility, because these materials will fail the testing protocol. So when we say, when you make a lamitube from, we get into the market, we have to say, is it in the yes category or the conditional category or the no category? And that can be decided based on all the components that have been used. What kind of, so here you can see it becomes a no category because it's a metallized level. It has some component which is not compatible when we want to process the polymer, or we have to take care of the different compatibility or mixing behavior in this. So we have to now understand this, and our recycling industry also has to look into this. they have to have a understanding and awareness and knowledge in this, and they will be able to say that some of this material they will be, or in the green zone, they will be able to process it and give it back to us with the value addition, and that can be used. The steps are very huge, and you can see that we have a commercial waste which is segregated. Then we have something which is called incinerable solid waste. Then we are called a non-incinerable solid waste. We are actually trying to work more on this for composting, etc. But when we say incinerable, then also you can say that whether it's a recyclable plastic, and from there whether we're going for waste to oil, we are going for road construction, or we are going for recycling. If it is a non-recyclable, they will go for different other energy recovery, co-processing in cement kiln or the plasma pyrolysis. So you can see that it has been shown also based on the different variety of material. It has also been shown as a different recycling systems that have a degree of recycling in this case. What it leads to, that recycling, as I said, that we have to move into recycling into post-consumer resin, and that has to have some value. You can see that. So we should be able to go back to our original granule or replacement as a virgin granule. If we can do that, that is the most success story that we like to reach. So from these, we like to go to original resin possibility, and then they will go back as a feed system as a replacement of the virgin material, or the mixed product will give a recycled material which will be granulated, and then they will go to for different value added product by molding and other processes, or pipe making, or furniture making and other processes, which actually in the culture of socio-economy today will have a less value, and but we have a more value addition if we can go for the PCR product. I like to bring in some example which has been done. SL Propec has launched new recyclable HDP barrier tubes. So there is a lot of work and from SL Propec, and there are a number of patents have been developed. I'm showing you one or two of these developed work. I wish Mr. M.K. Banerjee, who has been involved in number of development of number of products, he should have given here some talks, and unfortunately he could not be here. So they have made mainly a pharma formulation, and they made a product with in such a way, because you have a body and you have this neck part of the product, and they have made in such a way to control the loss of aroma, because some of the pharmaceutical products within few days are losing their aroma. Based on HDP, they have developed a good chemical barrier, but because it has a limited moisture and oxygen barrier, so they have gone with different coating. And but aluminum foil reacts with the formulation, so it is not only bad for recycling, it is also bad for the product. Okay, and then delamination occurs and all that. So they have worked collaboratively with the company, with the Kurare, with the South Korea, and they developed a innovative binder based TiO2 nanocomposite based product for the tube shoulder, and which makes a huge value addition and recyclability based on the huge market value which must be going into commercialization and being in place. They have developed also many product in this. So it is called Platina 250, green GML 300 lamy tubes, as you can see that, and different brand of SL Propec product also going. There it is not only SL Propec, the many others. Procter Gamble also is coming up with the new packaging material for their toothpaste brand, and they feature recyclable high density polyethylene toothpaste tubes, and that already recyclable toothpaste tube, they've already started most probably in production, and they will go into full conversion of their product by 2025. So you can see that the commitment and dedication that the companies are taking into developing or redesigning material for that purpose into the tube, which will also have an environmental concern on recyclability. So I already said, but I like to mention here that SL Propec is currently selling tube with 25% PCR in the sleeve and 50% PCR on the shoulder, which is a lot of value addition. And with that HDP and with that mixed sample, they maintain the melt index of 0.3, and which can be blow molded into the 20-gram bottles and other products. So there are a number of projects going on in this where the recyclability of HDP barrier bottle, I talked to actually Mr. Banerjee, and I got a lot of information about how SL Propack was doing all the. Okay, Colgate also has come up with different products. Okay, and they also use RFID tag to track their tubes. So there are lots of innovation is happening, and which will add the recyclability, sorting, and collectivity of this product. LB also patented some their tubes, which has a 50% post-consumer recycle material, recycle HDP, and this is also, and they have 14% reduction in carbon footprint for these tubes as compared to the virgin plastic tubes. So you can see that we started looking at it, that the benefits not only from recyclability but also using for this. The other story, success story, is with the fillables. I don't know whether this will work, but the industry has started working it. This milk vending machine, the milk ATM like Mother Dairy and others, I like to take a name. These the fillables, or you go with your own can and you collect your milk and other products, becomes a very successful story. I would like to see personally that lot more fillable situation being developed for many products. So unnecessary using a lot of packaged product and throwing, that there we can go for reduction by this process. And you can see that here there's a refill station has been developed for different cosmetic products. Okay, where you can go with your container after it is being used and refill it. Okay, but one of the important point here one has to look into what is the transportation part is involved. If you have to bring back the used container and refill and giving back, it depends also on how if it is individually to be refilled, it may involve a lot of transportation. If there is a bulk way, it has been controlled from the main source to many other cities and many different retailers possible for the refilling, then I believe that there will be possible for refilling to be successful. Unilever is already talking about innovating for a reuse refill revolution, and they are also thinking of by 2025 that all plastic reusable, recyclable, compostable they will be able to develop, and they are already talking about some of their product, conditioner and shampoo and other products that they are actually using, which is called the refillery, and that can be reused and refill the time. Here you can see many beauty products. L'Oreal has developed refillable bottles, so one can, and this is growing. This is growing very much. That you can bring your used bottle and this brand, and you can see this another rechargeable packaging. So you can also, there is a new design by which they can be easily refilled and then you can take it back. So you have to have a new design in these containers or tubes and the product in such a way that we can go for this refillable situation. So recycling and refillables, okay, both have to work in a competitive manner, but in a very, very balanced manner. And we also have to give incentive to the people or the consumer so that they are being tested, tried, and being used so that we can take care of our recyclability problem in many different ways. There is many refillable packagings are already in the market. This is a kind of a moisturizer which can be seen as a beauty product, or there are different kind of packaging has been developed, okay, which has been researched in Germany, and they to compete with a single-use shipping packaging, and this has been advocated to go for as a mailing bags, which can be repacked in a reusable bag. And the way the digital marketing is going on now, and especially from a very recent pandemic situation, many are online marketing, shopping is going on. So these repack reusable bags will be a very valuable item for the retail packing, so that this can go back, and unnecessary, we are not using extra packaging, double packaging, triple packaging layers, and then throwing away for collection, sorting, or for landfilling. So when you want to look into this, the different innovative scenario that I've shown to you, it has to be assessed also. And when we try to assess, we try to assess what is called as a product life cycle. This product life cycle depends on number of steps. First steps is selection of low impact material. You cannot take any material. The material that we have to consider has to be non-hazardous, non-exhaustible, low energy content, and it should have a recycled material or recyclable contents. Okay. We should think of reduction of material. We should think of reduction in weight and reduction in transport volume, very importantly. What kind of thickness we should talk about? How much material is going into the lamitube? Can we reduce that option? Okay. Then we have to think of optimization of production technique. What kind of alternate production technique is possible, which has a low or clean energy consumption, which has a low generation of waste, and few production consumables that we have to see. We should have an efficient distribution system. So it should have a clean packaging, efficient transport mode, and efficient logistic. We have to also see. And we have to see that it has a low energy consumption, clean energy source, and clean consumables, and optimization of the lifetime, because it should also have a reliability and durability. If possible, it should have a modular product structure. Some of the fillable product, if you have looked into it, you can see that they are now being made as a modular product structure, so that the body may be remaining same, the cap and other parts can be replaced, so the whole of the package do not have to throw away. And so it needs a very classic design and user taking care of the product, how user is using it. And obviously, that in order to optimize the end of the system, we cannot say cradle to grave. We like to talk about cradle to cradle. So we should go for remanufacturing or refurbishing. We should go for recycling and cleaner incineration, so that we reduce the environmental burden. In order to do that, what we look into what is called a life cycle assessment as per ISO 14040, which has been drafted as a consecutive and interlinked stages of product or service. So nothing is holistically, all of them are connected. When you're using a product, you have to see is value addition, which starting from the raw material, which is coming from the extraction of natural resource, and to the final disposal. We have to connect it. And that's what life cycle analysis is, to preserve the value of plastics and to efficiently design the product for best possible post-consumer uses. And that is the ISO 14040 demands for this purpose. So how do we take care of this? Every product or which we can develop, whether it's a tube, whether it's a flexible packaging, whether it's a refillable, and then we look into the 4 stages for this: production of raw material, manufacturing, uses, and waste management. And this can be done across the board of the material, whether it's a plastic, whether it's the metal, whether it's the glass, whether it's the ceramic, or whether it's the paper. And then when we look at it, how much is the material input, how much is the water input into that, and how much is the energy input there, and then what is the emission and health hazard. Most probably that has been assessed by the machine that has been presented by Mr. Hinkopf from Mechatronica. Okay, and he mentioned that there are advantage of the carbon footprint. So the emission and health hazard, you have to look into the system. When we do that, this life cycle analysis can be utilized for comparison between products in selection and evaluation of grades. It can be between processes, method, and management. How do we are doing that? Product development, is it a green design? Is it eco design? Is it a green products, more environmental friendly? or it has a better eco-efficiency, that is economics and ecology together. How in the communication also we can use it, how we are reporting it, how we are environmental declaration we are making it, what kind of levels we are putting into that. And finally, life cycle analysis helps in decision making, management policy, and in evaluating. It can give a tool to the government to make an environmental tax or standardization and investment. And I think the newer policy and regulation which is coming will be based on more of this type of quantitative analysis of the life cycle of the product. As I said, that it involves number of steps. You have to define the goal and scope of the definition. I'll give you some example. It has to have an inventory analysis, and it's not very easy. It's an impact analysis. Very quickly, I will not go deep into it, but I will give you some idea how it goes. The goal means the product to be studied. It has to be identified what is the purpose of the study. The Lamy tube has to be studied. What is its intended application? How, to whom the results has to be communicated? What is the functional unit? How many Lamy tubes are being used? It has been talked about that 500 Lamy tubes are used for men, 500 Lamy tubes are different products are used for women. And then if you collect together per month, per year, what are the total amount of Lamy tubes that are being used? What is the system boundary? What are the types of environmental impact we are looking into? And then how many types of material is goes? And you look at it, at the bottom it is written transport, 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 and transport. So we go from manufacturing to use to end of the life. Everywhere this is involved. So manufacturing facility, distribution center, washing facility and waste. And this transport takes a huge amount of energy. It is not the material. Material may be very eco-friendly, but the how it has been produced and where it has been packed and where it has been consumed determines, and that life cycle analysis has to be done. And many a time we have to depend on the third party sources of data. Many of the companies, they are not are ready or being involved into give so many data. So many data which are involved, and number of life cycle analysis we have done for recycling of material. We dependent on many of the large companies who are involved in making the packaging product and leveling it, and then use it for the filling of those packaging and send it for the retailers. But generally very difficult to get some of the data which has to be collected. So once you do that, with the inputs and outputs of that, what I explained to you, you can assess this life cycle in terms of many of them. Global warming potential is one of them. Okay, we generally talk about GWP, global warming potential. You can talk about acidification in the atmosphere, ozone depletion, human toxicity, photochemical ozone, ecotoxicity, landfill volume. Everything can be considered, and lots of data is needed, and then it should be weighed and interpreted in terms of carbon footprints, greenhouse gas emission, and recyclability, which is very important. If we do that, if we see that the net carbon emission and net energy management, if you look at that, so carbon emission, if you look at that for landfill, for combustion and recycling, you can see that if you can do better recycling, you have a net negative carbon emission, which add value to the system, and even combustion give a positive net carbon emission, which is a concern. Similarly, the total energy consumption also can be evaluated. These are data for a particular, you can see that particular system which has been done by US EPA system and given these values, which actually used for assessing the different plastic products, that whether it will go for recycling and combustion, which I was trying to say, that more recyclability in a packaging product will give a net negative carbon emission, which is good for us. And that is, I believe, being some of the Lamy tube that I've shown by SL Propack or Procter Gamble, all these Colgate that they're using, they're actually working on this scenario. And even the LCA has been done for the glass bottle versus PET bottle. And you can see that for glass bottle, transport raw material, product, filling station to customer to landfill, all of them are sequentially considered, as has been considered for PET bottle on the similar line. This is a data which has been done in Turkey. They have done thorough analysis, and they have, based on the life cycle analysis, they say that what is the effect on the human health, what is the effect on the ecosystem quality, and what is the effect on the resources, that is by the glass bottle of LCA to glass bottle of PET, and one can compare. You can see and this can be used for selection of material and for the policy making. And we must, before we take any recommendation or decision, we must understand this kind of data for every packaging material and every packaging design and innovation that we are doing. I will very quickly talk about one of the recently studied life cycle analysis based on the thickness. So we have taken some packaging of polyethylene, which is of 35, 50, and 100 micron. As you can see, this is also a concern in the new regulation that is coming with the single-use plastic situation. I told you that you have to decide functional unit. So we talk about 1 million bags of these different thicknesses, and then if it is recycled, then what the life cycle analysis data says. So we have gone from granules to the film to the bag to the waste to recycling, and then finally get back into a PCR granules, which post-consumer recycled, which can be maybe moved back into the granules as and when needed. And we call it a cradle-to-cradle system. So you can see that it has the life cycle analysis module consists of 3 different stages. First is crude. From crude to product, we do not generally look into it. We look into the lamy tube. But the lamy tube has come from HDP, LDP, and other granules, other polymer product which has been formed. And this is the first part of the module. Then you come to the module 2, where the module 2, so in the first part also material, energy, and emission is involved. In the module 2, when it goes to retailer, to the user, we are using it, there is also energy and emission is involved, because this has to be transported, this has to be shelved, this has to be collected, and then is used. And then we go to the module 3, where is very important, where is the post-use waste is there, whether it goes to landfill, collection, sorting, reprocessing, and product. Each and every blocks which you can see that we have done the material, energy, and manpower requirement and the emission that will be coming in. You'll find that the module 1 we can do with the standard data and analysis. The first module is now becoming very standard data analysis. Module 2 is critical data to consider. Where is this granules is going to go and make a packaging product? How far they have to be traveled? What is the transportation mode and what is the transportation route, and how it is coming to the user? And module 3 is critical to incorporate, even in as per the standard LCA method. The data for this is still yet to come in a very organized manner. This is quite a bit of unorganized sector, and LCA module depends on this. So where the lamy tubes after use are going, so many lamy tubes are going, how they are being collected, how they are being sorted, had to be looked into in a manner. I will just not describe this, what I have discussed in the previous slide. You can see that module 1, module 2, module 3, each and every aspect of that has been done, and with the software we have done. But what I want to talk about it, we looked into it that with the 2 scenario, it's a gate cradle to cradle, you can see that, okay? And we thought that if we use 80% recycle, if we use 72% recycle, what happened to the system? So each case has been analyzed, and it has been analyzed in terms of different impact categories. Okay, so as I said that as a global warming potential, which has been looked into in terms of CO2 emission, carbon monoxide emission, methane emission, acidification potential, which has the SO2, NOx, and HCl, which gives the acidity value, and the environmental other potential with the phosphate and ammonia, which is there, has to be calculated. And then there is a factor is given that we say there is a carbon dioxide emission. We talk about carbon footprint. What are the factors? Okay, and that what equivalent makes a one equivalent of a CO2 emission, which has been done. How many kgs of CO2, how many kgs of SO2, and how many kgs of phosphate being developed. That has been put together. It has been seen that by changing from 35 micron to 35 micron to 50 micron thickness, our GWP is increased by 72%. And it increased to more than 300% if you go to 100 micron. So just saying that 100 micron better, we have to look into that. But we may have to do that because of the collectivity, sorting, and ease of waste management. I understand that. Okay, so the magnitude of carbon footprint remain around 77 to 90%. Okay, until and unless there is a possibility in recycling efficiency improvement is there. We went back and we put 25% of the recyclate back into the as a virgin material replacement, which is becoming the norm, that by 2023 we should have 20 to 25% PCR back into the making of the bottle, making of the container, making of the lamy tube, and that is as a replacement of the virgin material. And you can see that by bringing 25%, we are reducing global warming potential by 28% and 137% for 50 micron and 100 micron. So if we have to use 100 micron, we must think of this PCR coming back, and that is reducing 137%. And if we can increase this 25% to 50%, most probably we'll be able to very close to offset this 300% increase in environmental concern, environmental load, and we may offset by reducing it to maybe 250%. So we have to look into this and we have to balance, and this should give a policy document, a policy suggestion, why we should go for 50 and why we should go to 100 and why we should be going above 100 for this purpose, until and unless we have a proper recycling back and replacement of the virgin material. Just increasing the thickness, I don't believe gives a proper solution for this. So I make a kind of a seesaw balance for this purpose. And if you look at it, this is the material impact, the heavier one, which is pushing it back. Go to 100 micron, you'll push it back. But if you increase the recyclability, most probably finally you'll be able to balance it. And this if we can balance it, we should go towards this lower carbon footprint if we can put this thing down. And that's what I have shown that the PCR is coming back. So what is the recommendation? Recommendation is that the thickness impact, lower to higher, could make a net negative for the environment in terms of the carbon footprint. And as I already said, I need not read all this. As you know, that UNDP by 2030 is asking for 75% virgin feed shall be replaced by PCR. And I think all lamy tube manufacturer, all refillables, all other packaging material, they must be working for it. We have to work together. And how this should create an improved collection. This should have a recycling infrastructure and process development. This will reduce the environmental burden, and this PCR application to new products and new application should be explored. So this is generally done. So how I end up my talk by giving you a little idea about that. We should, what I call it, a life cycle thinking. We should think that way. And this is what the life cycle thinking is asking. It is asking that what I presented, that we must be defining recyclability. We must be establishing recyclable hierarchy. Just saying that this will go to lamy tube or this, we should have a hierarchy that which goes where. HDP is better recyclable, and that's what the companies are introducing this. What is the effect of recyclability due to the presence of similar or non-similar material? We should look into it. What is the policy should be for material reduction? I explained to you. Is it in terms of thickness versus collection versus recyclability from waste? Shall we use synthetic versus biodegradable nature of material? Then if it is a biodegradable material, then what is the environmental benefit? coming from the resource to the material. And single-use plastic has to be evaluated, although single-use plastic was a savior actually, and so widely used in the present pandemic situation. I have been involved in many, some of the few product development, not many, some of the few product development, and I can see for our healthcare workers and everybody, and for all of us, even for digital packaging and marketing, the single-use plastic become very useful for this purpose. So what I request that minimize through the regulatory intervention and landfill taxation, and maximize through the awareness campaign, we can reach to beneficial use of material and energy. From we should reduce as much as possible of landfilling, and we should move towards that this hierarchy I had showed before. I like to end saying that we now are a part of a knowledge platform, which is a foundation for innovation packaging, innovative packaging and sustainability. You can see that, and we have our website where we are actually taking care of a lot of knowledge-based personal development, technology initiative, coordination among R&D program, international cooperation, stimulate this resource efficiency and recyclability, which I'm talking about, life cycle analysis, and how to use this fourth industrial revolution, Industry 4.0, in the packaging and all that. I'd like to end my talk thanking you. Lot of analysis, which I was just giving a preview to you, was by a lot of organization who are involved and giving us, providing a fund of the project, which has given a lot of value to our talk. Thank you very much.
Thank you, sir. Very thanks, sir, for deep, information shared with you to us. In fact, many of us were not aware of it. So much deep information is required in this subject, and you started with the very basic and ended with the commercial implication of this recyclability and also policy which is involved worldwide, carbon footprint, and also new technology in the single polymer which to be used for different polymeric applications. And also you have shown the many of the examples on smaller plastic items, flexible packaging, plastic bags, beverage bottles, damages, the implications on the recyclability. You have also shared the information on multi-material to mono-material. Neopack is a new material which has been introduced in the market, and companies are getting benefit out of it. Different companies like Hindustan Unilever, then starting from Colgate, and then L'Oreal, so many companies they have started, Procter and Gamble, how they are getting running all this polymeric application in the recyclable packaging materials, and how much benefit world will be getting out of it. You have very nicely elaborated information given a life cycle analysis, carbon footprint, and the chart which you have shown is a very informative and useful to all of us. Basically, West hierarchy, the pyramid, and later on you have also given the different data on how the recycling is helping to reduce the pollution as well as all types of carbon footprint. And I'm not going to detail that all of it. Really a wonderful presentation from your side, and all of us, starting from academic and industries, will get benefit out of it. I request everybody to give a round of applause to Dr. Professor Joshi. Before ending the presentation, I would like to request you, if you have any questions, quickly you can put up questions to sir that is available. Then after that, it will be given to Praveen Mahajan sir. Yes. Any question, please? If you have a question, you take the microphone and then come and sit here. You say your name and background, then you speak.
my name is Aman Ahmed. I'm a student of IIT Punjab. Okay. My question is, what FDA guidelines say for the use of PCR in personal care products? I mean, I mean to say at what percentage they are eligible to use in personal care products.
Professor Ghosh said,
Yeah, can you, Madhav, can you translate? I could not hear properly. Can you repeat?
what is your question? Give it to me. Sir, he is a student of IIT Delhi. He has asked that what FDA guidelines says for the use of PCR in personal care products. And that is on the percentage wise, he is asking for personal care products for the guideline.
Yes, the PCR, the PCR also very good. If the PCR has to be also tested, evaluated in terms of the all guidelines, PCR has to be also, we are looking into it, that finally PCR can be used into the food packaging also and the pharma packaging also. But before that, we also have to go through a lot of guidelines, the regulations. A lot of companies, I know Procter Gamble personally asked me, if there is any BIS and other guidelines are there, they're ready to go for all this testing before they can use for the healthcare or personal care products and the food products. But obviously, for the food and all that, it will go with a lot of evaluation and testing procedure. But the PCR can be used as one of the internal layer in the multi-layer system. Okay, so that can be done very easily, but not in a direct contact with the food and pharmaceutical product. So I think there are lots of evaluation and guidelines are coming and will be coming very soon. And this is a good concern, and we are already working on it. But I don't think we have that, and all that. That's what I said, that the testing protocol also has to be connected to this.
Yes. Thank you, sir. Any other question you have?
But there are lots of products where it can be already used, which are not. I know the sensitive thing is for the food packaging and maybe some of the personal care product, but there are lots of other cases it is already being used.
Yes, sir. Yes, sir.
Which are not so sensitive for that purpose.
Yes. Any other question you have? Anybody from this side? You have any question? So, as there is no question, thank you very much, sir. Now over to Mr. Praveen Mahajan, sir.
Thank you, sir. So we are at the end of the first International Tube Manufacturing Conference. This conference, as you know, was organized by PhD and Tube Promotion Council. Tube Promotion Council, as the name says, is the body, is the association which is trying their level best to promote the tube business in India as well as in Indian subcontinent. They have conducted up till now 4 webinars on tube manufacturing, and this was the first hybrid conference. Now, in this conference, we really wanted to touch upon all the topics of the tube ecosystem. So we started from raw material, which is laminate. Then we talked where Mr. Balaji and Mr. Ram gave a nice presentation on the new development and the 9-layer laminate film, how it can be beneficial in various aspects. After that, we spoke about the tubing methods. Mr. Miroslav explained about various technologies that is available. Mr. Hans explained us what different geometrical shapes are available and how it is beneficial. Mr. Daniel explained us various printing technologies. Then we also looked into the aspect of tube manufacture. UFlex really gave us an insight about what different valuations they are doing for their customers by developing new applications. And we also saw this whole aspect from the tube buyer's point of view. Mr. Gagandeep explains what exactly a print buyer looks into a tube supplier, how he selects the tube, how he selects the laminate, and how he finalizes on the design. So when we discussed, we have covered all the aspects, and on top, we also, as a responsible citizens, we also have touched upon the recyclable aspect of this laminate. So in nutshell, we have covered all the aspects. I really want to thank New Promotion Council and Mr. Bhatia, who has made it possible to bring all the speakers for this forum. I also want to thank Mr. Singh, Mr. Naveen, Mr. Rakesh from PhD Chamber of Commerce for organizing this event. Besides that, we have a lot of speakers with us, I think from Mr. Balaji and Mr. Ramswarup, Mr. Gagandip, Mr. Bhatia, Mr. Miroslav, Mr. Hans, Mr. Daniel, and then we had the expert team of Mr. Tanviralam, Mr. Madhav Chakravarti, Mr. Deepak Manchanda, Mr. Ghosh, and one person who was not part but who also has helped us a lot is Mr. N.K. Banerjee. So I really want to thank all of them and also all the attendees who have attended this program. You have given your valuable time. I hope you have found this initiative by Youth Promotion Council as a good start. We will be conducting such programs more often. And if I have missed anyone in saying thanks, please excuse. With this, we are at the end of the program. Thank you all. Have a nice day.
Okay, I will just return.
Yes, sir. Most of the don't take care too much about it. Only this afternoon is still business time. Yes, I'm there. Yes, you can have or something. Tomorrow, just you don't need to make small, don't make it. And depending on when you're coming, you find back fitting in your schedule. Otherwise, the topic don't work. Yeah, and then we only do it tonight. So we can even go to the restaurant. Tomorrow, short quick, okay? Okay? I do otherwise. If there is any other अरे नहीं मैंने उस मेरे को कर रहा हूँ Yeah.
मिनट भाई वो लैपटॉप किसका लगा था? इसमें क्या कर दो? इसमें क्या कर दो? इसमें और करना कॉपी नहीं नहीं कुछ करने जाएगा तो मैं मीटिंग खत्म हो गई? हाँ जी।